Okay, so the today's topic is Chomsky's normal form. So in the Chomsky's normal form, there is a set of production rules which we need to follow in order to convert any context-free grammar. So what are the rules? The rules are that the production can produce one single terminal, or a production can produce two terminals without any other terminal or non-terminal. The length should be not more than 2, or a start symbol can produce epsilon, and this condition is only appears when the grammar accepts null string. So these are the three possibilities of the production. If any of the set of grammar contains productions which satisfies these rules, we can say that the given grammar is in normal form. So we can see some examples over here, that if a grammar is producing 4 different productions, and if every production is satisfying the Chomsky's rule, then we can say that the given grammar is CNF. So in this case, the grammar number 1 contains all the productions having the similar structure which we need in CNF. So CNF is saying that if the production is producing one terminal, so the very first production is producing one terminal, it's fine. The other production is producing exactly two non-terminals, then it is okay. If a production is producing terminal, then it's once again fine. So the G1, the grammar number 1, is completely satisfying the CNF rule. So let's see the example number 2. The example number 2 is containing 3 different productions. The first production is fine. The second production is not in the structure which basically CNF wants. So what CNF wants? CNF wants either one terminal or exactly 2 non-terminals. So in this case, there is one terminal along with one non-terminal, so this is not acceptable. So that's why this whole grammar is not CNF. What shall be the steps of conversion of any context-free grammar into its normal form? The very first step, we need to have a new start symbol. Second step, we need to eliminate all the null productions, means those productions which produces epsilon. Then we need to eliminate all the unit productions. What are the unit productions? Any production which in which the producer is producing one non-terminal. So if any of the production is producing one terminal, then it's fine. We cannot say this is a unit production. The step number 4, we need to eliminate terminals from the right hand side. If there are terminals, multiple terminals, or terminals along with non-terminals, we need to eliminate terminals from them by using decomposition technique. What will be the decomposition technique? We'll see later how we can decompose by introducing new productions. Step number 5, again we need to decompose the productions if they are containing more than 2 non-terminals. So we need to decompose and reduce the size accordingly. So let's see one of the example over here, that we are having a context-free grammar which contains different productions. There are 3 non-terminals as A and B, and there are 2 terminals, small a and small b, and we do also have epsilon. So the very first step is to make an augmentation. So how we can augment? We simply introduce a new start symbol, that is s dash produces s, and then we need to rewrite the whole set of productions along with the new productions. So every time we need to write the whole set of productions including the new changes. So in this step number 1, we introduce a new production along with the new start symbol, so we add this production along with the remaining grammar productions. Step number 2, we need to eliminate all the null productions. So first we need to identify what is null production and which one is the null production. So we have one null production, that is A is producing epsilon, and in this case we need to find out A on the right hand side of all the productions, and we need to identify those productions which contains A on their right hand side. So here we identified three productions containing capital A. On the right hand side, the very first S is producing A as B, the other one is A is producing small a, capital A as, and then B is producing capital A. So these are the three productions. So what we need to do, we need to eliminate A and we need to substitute A with epsilon. So we don't need to write epsilon with any of the terminal or non-terminal in any of the productions. So what we need to do, we need to simply delete A from these productions. So these are the three productions we received after removing A. So in S we simply removed A, in capital A we removed capital A in the production, but in B we removed A with epsilon because A was alone. So if we remove A, we need to write epsilon instead of A. So after doing this step, we need to rewrite the whole grammar along with the new production, and keep remember that we removed A produces epsilon, that was the null production which we were removing. So S dash produces S is fine, as is producing A as B, the previous production which was already in the set, and we introduce a new production, that is SB from this side. Then A is producing A as A S, and A is producing small a, and then a new production, that is A is producing small a and S. B is producing all the previous productions and a new production, that is B is producing epsilon. So here a new null production is yielded after the substitution of epsilon. So we need to eliminate this production as well. So now we recheck the null production, and we found that there is another null production, that is B produces epsilon. We need to do as same what we have done with A produces epsilon. We need to find out B. On the right hand side of the productions, we identified these two productions. We simply remove B with epsilon. So we received a new set of production, that is S produces AS and S produces S. What we need to do, we need to rewrite the whole grammar along with the new productions. Keep remember that we need to eliminate B produces epsilon from the resultant set of productions. So here we are not writing B produces epsilon, we are simply writing S produces capital AS as well as new productions. So keep remember that whatever comes in red, it's the new entry. Step number 3, we need to eliminate all the unit productions. So we need to identify the unit production. What are the unit productions? Any non-terminal is producing one single non-terminal is known as unit production. So here are 3 unit productions. S dash produces S, S produces S, and B is producing A. Rule of thumb, the very first thing, if any of the non-terminal is producing itself, then we simply delete such production. So here S is producing S, we need to eliminate this production. Here we are not going to substitute or write any other production, we just need to delete this production. For the rest of the unit productions, what we need to do, we simply substitute all the productions of that particular non-terminal wherever it appears in the unit production entry. So let's see how we can do it. So S dash produces S, what we need to do, we need to write all the S production by removing this particular S. S produces S, just delete it. B is producing A, we need to write all the A productions. So we have done over here, and we received these new productions. So S dash produces all those productions which were technically belongs to S, and B is producing all those productions which were technically belongs to A. So here we are rewriting the productions. So S dash was previously producing S, so here we removed that S and we are writing all the productions which were related to S. B was previously producing capital A, and now B is producing all the productions from A. So this is the step in which we are removing unit productions. The step number 4, eliminate terminals from the right hand side. So we need to identify those productions in which we are having multiple terminals or terminals with non-terminals. So A is producing a terminal along with some non-terminals, and A is producing a terminal along with one single non-terminal. Similarly in B we are having non-terminals, n-terminal and non-terminal, or multiple terminals. So we need to identify such kind of productions. What we need to do, we need to identify what terminal we are getting in these particular two productions. So we identified that we are having one terminal and the other terminal is B. So we produce new productions by introducing two new non-terminals, that is X or Y. We can use any of the name. It is not mandatory to have X or Y over here, but it should not be from the set of variables from the given CFG. So it should not be S, A or B. So we can take X is producing A and Y is producing B, and now wherever we are having a small a and a small b, we simply remove those terminals with the new non-terminal entries. So here are the new productions. A is producing XAS and XS, B is producing SYS, B is producing YY, and B is producing XAS, and B is producing XS. So here we simply removed those terminal entries from the production. So what we received these two productions, which are basically X produces A, Y produces B, and a set of production in this particular box. So what we need to do, we need to rewrite all the grammatical productions which we have done previously, and along with these new productions. So the set of new production is like this. So S dash is producing previously as it is, S is producing as it is, A is having two different new entries, B is having four different entries, and X is a new production and Y is another new production. So what we are making over here in this step, we simply add those entries into the grammar. The last step, we need to decompose the productions which are having more than two non-terminals by introducing new productions. So how we can do it, we need to identify those productions, the productions which are having multiple non-terminals, but these non-terminals should be more than two. So here we are having S dash is producing three non-terminals, similarly S is producing three non-terminals, A is producing three non-terminals, B is producing again three non-terminals and another three non-terminals. So it's by chance there are all of them are of size 3. So what we need to do, we need to get first two non-terminals, and these first two non-terminals were associated with another new non-terminal by making a new production. So we are making U is producing AS. So wherever we are having AS, we can easily put U instead of AS. And there is another production, that is SYS. So we can take SY, the first two non-terminals, and we can have a new non-terminal V. So we can remove SY with the help of V. So by removing these productions, we can reset the size of these productions which are having more than two non-terminals. So let's see how it works. So we simply remove those entries with U and V, and we can rewrite the whole grammar once again with the new substitutions. So S dash is producing UB now. Previously it was producing ASB. So now AS is received with the help of U, so we can easily use U instead of AS. So we can use any of the name, whether it's U or V or W or anything, but it should not be as same as what we have received previously from the given CFG. So let's see how it look like. So in this case, all these productions are satisfying the Chomsky's normal form rules. What were the rules? A production can have two terminals, exactly two non-terminals, sorry, or a production can have one terminal. So let's check. S dash is producing two non-terminals, fine. S dash is producing another two non-terminals, fine. S dash is producing another two terminals, fine. Same as having all the productions perfect. A is producing two non-terminals, perfect. A is producing one terminal, again it's perfect with Chomsky's normal form. So all of these productions are having similar design what we need to satisfy Chomsky's normal form. So let's see the final picture. The final picture is shows that CFG, which does not have any kind of rule of length or the starting of any terminal or non-terminal. So CFG is very versatile in its design, so that's why it is difficult for any programmer to program CFG, because it can have any length of terminals or non-terminals in their productions, and there is no rule for the combination of these entries. As well as there is another thing which is basically your null production, which always creates a complexity. So here in the Chomsky's normal form, we can say that if any of the production is starting with the non-terminal, then this production can have another non-terminal and the length should be exactly 2. Or if any of the production is producing one terminal, then we can say that this production simply contain one terminal. So we need to reduce any of the non-terminal with the terminal. So this is the final form after applying all those 5 steps. So thank you very much. Let's see some other slides.